For today's lesson, our objective is to express a fraction with a denominator of 10 as an equivalent fraction with a denominator of 100. So remember that fraction and decimal are the same thing. They only represent a small part of a whole number. Let's review some vocabulary. Similarly to a decimal, a fraction only represents part of a whole number. So here I have the example 12 hundredths, and 12 is the numerator. The numerator is a number on the top. A numerator will always tell you how much part of the whole thing you actually have. So the numerator here is telling me I actually have 12 out of 100. 100 is the denominator. The denominator, which is always on the bottom of the fraction, tells us the amount needed in order to make a whole. So this fraction is telling me that I only have 12 out of 100 that is required to make a whole. Using base 10 blocks, this is how you would represent 12 as the numerator. And this is how you would represent the denominator, 100. So this is showing me that I only have 12 out of the 100, which is a whole. So as you guys notice in our Google Slides as well, if a fraction is not written like this, it's written with a slash. The numerator is always first, here is 12, and the denominator, the bottom number, is always on the right here, 100. So like I mentioned, our objective for today is to use a fraction that has a denominator of 10 and find its equivalent with a fraction that has a denominator of 100. Equivalent fractions are numbers that represent the same value. So even though the digits might be different, it's still representing the same amount. Okay, so let's look at this example. So let's pretend that these two circles are identical. And let's say that I want to represent half. Well, one way to represent half with the fraction is to cut this circle in half down the middle, shade in one side, and now this circle is representing 1/2, right? Half of the circle is colored in. Let's look at this another way to represent 1/2, but I'm going to cut this circle into 4 different pieces. Because a denominator tells me the total to make a whole, the total here is 1, 2, 3, 4. That's the denominator. But I still want to represent half, like this one. Even though the total is 2 pieces and 1 is colored in, I can't just color in 1 because that doesn't look the same as this. So I need to color in 1 more. Now once I did that, how many pieces did I actually color in? I actually colored in 2. 1, 2. So that's my numerator. These two fractions are equivalent. Even though the digits are different, they still represent the same amount, meaning half of the circle is shaded in. So how is it possible that a denominator of 10 can be equivalent to another fraction with a denominator of 100? Well, that's because all of our numbers are based off of 10. It's really easy to see using a base 10 block. We all know that this represents 100 little squares, and all of these 100 little squares make one whole, right? However, we also know that 100 of these can be broken down into groups of 10. So we know that it requires 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 to make one whole. So it is possible to have a equivalent fraction with a denominator of groups of 10, because 10 groups of 10 eventually lead out to 100. Now this work is only possible when we're talking about numerators and numbers that already are in groups of 10. So let me show you some examples. Okay, so let's look at this example. Here we have a hundredths grid, and this is a hundredths grid because there are 100 squares to make up a whole. And this is a tenths grid because there are 10 pieces that make up a whole. On the hundredths grid, I had squared off a chunk, and I know it's difficult to count. However, there are 3 columns of 10, so this is 30 hundredths. The numerator represents how many I've selected. 100 represents the number total to make the whole. So this is on a hundredths grid. If I wanted to represent 30 out of 100 on a tenths grid, how many groups of 10 did I box off here? Well, I boxed off 1 group of 10, 2, 3. So in order to show 30 100ths on a tenths grid, I just need 1, 2, 3 out of the 10, 3 out of 10, to represent 30 hundredths. These are equivalent because if I take this chunk that represents the 3 out of 10 and I lay it right on top of these guys, whoops, here we go. It's the same thing. 30 over 100 is the same thing as 3 over 10. Also, another trick is if you just cover the zeros here, you could also see 3 tenths, 3 tenths. 30 over 100, 3 tenths. Same thing. Let's look at another example. On the hundredths grid over here, I have squared off 60 out of 100, 60 hundredths. To represent this same amount, out of 60 100ths on the tenths grid, I need 6 pieces. So 1, 2, 3, 4, 5, 6. Here I've selected 6 out of 10 totals. Let's double check to see if 60 hundredths are equivalent to 6 tens. I am just going to lift up my pieces of 10 and I'm going to place them over the hundredths grid as well and see if it matches up. Okay, sure does. 6 of these represent groups of 60. And that is because one group of 10 represents 10 different little cubes, just like on the hundredths grid. It takes groups of 10 to create 100. And it's very easy to find their equivalents. Okay, so let's look at a different example. Let's say instead of 60, I actually had 62 hundredths instead. So let's get that there, 62 hundredths. And because this is 60, I need to add 2 more cubes. So we'll add these guys in here. So 62 hundredths. Now, as we confirmed earlier, 60 is equivalent to 6 pieces on the tenths grid. However, I can't break one of these groups of 10s into 2. So, I mean, it's a whole one group of 10. So I cannot find an equivalence of 62 hundredths with a fraction of, with a denominator of 10. So this only works if the numerator, which is the number on top, is a group of 10. Meaning that there's only in the a digit in the tenths place value and not in the hundredths place value.